Hey, today I want to give you my personal opinion about the software production landscape in 2021, and I will also refer to software supply chains. Every useful piece of software starts with a clear and well-defined problem. Many people believe, especially entrepreneurs, that finding a relevant problem that is solvable with software is a critical task, because a big part of the future failure or success heavily depends on this very first decision. Two typical problems to solve with software are saving people's time and money. Once the problem is properly defined, then we need to have a realistic idea on how to solve it, technically speaking. In medium and large software organizations, these ideas lead to people who are going to decide how to solve the problem. Those are the people that are going to take the technical decision. And it doesn't matter what kind of problem you have at hand, it is always a people's problem. These people are organized in a hierarchical manner depending on the organization. Typically, CEOs, CTOs, and stakeholders are at the top, while software architects, designers, engineers, and junior programmers are at the bottom. Normally, project managers and architects discuss a very high-level solution to the problem. Once they agree in a particular solution, then they write a document. It is a formal document that contains the functional and non-functional requirements to the software to be built. Then, a team of engineers receive this document and the coding begins. Developers rely on a production environment. They use version control systems, IDEs, and all sorts of productivity tools to write code, write documentation, define coding conventions, submit tickets, make pull requests, fetch dependencies from package managers, and so on. Notice that at this stage, both code and documentation need to be written. So this process produces both code and scripts. These two then go to some build system which compiles the code, packages dependencies, executes tests, and performs some quality assessments. The goal is to build the application and produce binary files. Notice that fetching packages and artifacts from external packages managers is necessary at this step. Once the binaries are ready, then it's time to deploy the artifacts to some external provider. Normally, this provider is a cloud service, such as Amazon AWS, Google Cloud, or Microsoft Azure. This involves a series of decisions, such as versioning, orchestration, security audits, performance tests, and so on. The process of integrating code into a mainline code base is called continuous integration, while integrating the changes made on the code base to the customers is called continuous delivery. But as most of you should know, this is actually not the end of the story. This is because once the software is deployed and is running, what we have is actually a product that needs to be maintained. Clients start to interact with the system. They usually report bugs, ask for features, or ask for documentation. Developers, sometimes with the help of bots, need to perform many maintenance tasks on the production environment. For example, monitoring the performance of the resources in the system, adding more documentation, or watching dependencies, the health of the dependencies in some vulnerability databases. As we observe, this is a complex process that involves both people and software. And this process is known as the software supply chain. The software supply chain is necessary and also presents several risks. Because notice that the whole process is software-based. So bugs may appear both in the software written by the developers and also in the software that is fetched from third-party vendors. At the end, the product distributed to the customers includes a lot of contributions not made in-house. Also, if an attacker managed to inject malicious code into the CI/CD pipeline, then the whole system gets compromised. And this is actually happening. The SolarWinds incident in 2020 is a clear example of this. In this, a malicious attacker changed the source code of the deployment infrastructure. From that point on, the software was compiled, tested, and deployed into the SolarWinds platform. After infection, the code was dormant for 2 weeks. After that, it mimicked another protocol to exfiltrate credentials. And these credentials were used to craft security tokens, which allowed the attackers to get confidential data from the customers. Supply chain related attacks are perceived as very dangerous and very difficult to detect. Current research made on software supply chain aim to hardening the whole CI/CD process in order to protect both the client and the software providers. This involves many tasks, such as enforcing security policies, taking care of dependencies, ensuring code quality, respecting licenses, and overall managing the whole process. So, in conclusion, real large-scale software production is a very complex process that involves both people and software tools. It also depends a lot on third-party applications, and because of this, there is a large risk of propagating malicious functionality through existing distribution methods, from the dependencies from the resource suppliers, and not to forget the hardware infrastructure as well. Thank you very much for your attention.